So first thing first, make sure you have your stuff sorted, get the prizes. Thank the sponsors, really. They are the ones who bring this together, and every year we have this amazing conference. And for me personally, it's really good to be back. I haven't been here for a few years now, so really good to be back. And yeah, let's enjoy. A little bit about myself. Started as a software developer, went into all sorts of different areas, consultancies, software companies, joined Microsoft as a trainer, and recently I joined a startup leading the engineering teams in the Gen AI space. So sort of been around for a while, and this particular talk inspired because we ran into a security issue, and that got me thinking on why it happened, how we could have prevented it, and so on. So let's go through a little bit of details there. You can find me at regular social medias, Twitter, it's now called X, and so on. Well, here's what we're going to cover today. So we're going to talk about the importance of security in terms of coding, of course. There are security measures that we need to bring to our software lifecycle, not just from the coding perspective, infrastructure, and all of that, but as a developer, let's focus on something that we can solve, right, and all the other aspects of it, but we definitely go through some of those. We'll also, of course, talk about, let's go back a bit. This goes too fast. There we go. We'll talk about some of the basics, so some principles when it comes to secure coding. And mainly, we are focusing on web-based applications, but this could happen like in many other areas. It doesn't necessarily need to be web-based, but the web-based are probably the easiest ones to solve in general. We'll talk about handling sensitive information, input validation, some of the interesting stuff back there. I'll mainly focus on C# and JavaScript, but this could happen like in any other area like Java, Python, all those other areas. And we'll basically wrap things up by talking about how do we actually prevent some of these attacks from a development perspective. So what do we need to do to not let this go instead of trying to fix it afterwards? So the importance of security coding basically comes back to, first of all, understanding how vulnerable we are as an application. What sort of areas do we need to focus on? Minimize those vulnerabilities if we find any. Of course, that's given. We have to find them before we can think about them. And the last thing is, and the most important part of it is user trust. So if we build a platform and users are coming in and signing up and so on and so forth, they really need to trust our platform, otherwise we lose the market. So the value comes back to us at the end of the day. The more secure application is, the better users are getting advantage of it, and the trust automatically brings more people in and so on and so forth. It's becoming like a sales pitch, but it is not really important. Why do we care? Well, if you think about it, even in Australia, in the last few years, there's been many, many incidents, large scale, and these are some of the big ones. Right? So Medibank, probably everybody knows about it. Optus went down. A lot of services from even government-related products where you would think the security is like the core, you would think they have many processes in place to security application, put a lot of effort and money into building that product in a stable and secure way, but it's not been the case. When we look at all of these, and by the way, who here is in the mailing list of Howard B. Pond? You will get emails right, left, center about vulnerabilities. My password was found in this particular breach, and it's just becoming too regular. It's sort of making us insensitive about it, which is dangerous. Because when you get regular alerts, you would automatically put them aside. So okay, this is happening like too much. Let's really not focus on it. So we know it's really important. But what can we do about it from a software development perspective? So the first thing is, first of all, where do we start? Do we need to, like, as a developer, when I was developing, early days of my career, security was the last thing. I didn't even sometimes think about it. I thought it's somebody else's problem. But then as we grow, as we evolve as a developer, as a team player, when it comes to working in a larger environment, you realize that you really need to understand some of the basics, some of the concepts. Once you do that, you automatically get involved in implementing some of those measures, which helps us to prevent some of this stuff from happening. For example, we all know sometimes the attacks are super stupid. Like if somebody comes into your form and you have an input field and somebody enters some sort of a script there. Remember, we used to test these stuff and send some sort of a script back into the browser. It would run maybe an alert or something, but that was like the visible stuff. The dangerous stuff is where you don't notice something is being injected into the app and it's running behind the hood. So, generally speaking, if you categorize these, there are many, many categories. Here are some of the important ones. First of all, it comes back to who has permission to do what. And here we are talking about legitimate users, not those who are trying to attack the system. So from those users who have a valid username and password, they've gone and set up maybe some sort of multi-factor authentication, they come into the application, what do they have access to? If I'm a user, do I need to get access to administration panel or some sort of a setting where I don't need to really know about? How much risk is going to pose to the application if I do get access to that part? Because I haven't gotten any training. I don't know if I change some setting, it's going to cause some problem elsewhere. The other thing is we need to do validation or all of these principles we're talking about. We can't just do it in one place. If you're doing it at the browser side, normally speaking, it's really easy to circumvent that stuff. You could easily change a little bit of code, even in the browser, after you've logged in as a legitimate user to try to circumvent the security of the application. So not only we need to implement these on the front-end side, we also need to implement it on the back-end side if you have any. And that's excluding all the other infrastructure level, like firewalls, web application firewalls, allowed lists of domain that you need to allow to get access to your application. All those other measures are outside of this scope. Here we're talking about code. Then we need to figure out, okay, we've done all of the stuff that we could think of, because security can be very expensive. How much money are you willing to spend on fixing security-related stuff? Because sometimes you think about it, it comes back to value proposition. So if I fix this bug, first of all, how probable is it to happen? And if it did happen, what would be the effect on my applications and the users? Sometimes they're innocent, things might happen, and you accept the risk. You say, I'm okay with this to happen as long as I know the scope of it, as long as I know what's the impact on the real users, and so on. So we need to know what do we need to do, first of all, in terms of security. Once we have that scope, we need to go and implement it. But then, if something happened, what then? So we need to know how to fail securely as well. It's not just about preventing it. It's about, what do they call it? Embracing, or I don't know, bracingly fail a particular security incident to not allow it to impact any other area. Maybe it's only impacting one area. Keep it simple. This is something that has been discussed many, many years. We had the last talk talking about not overcomplicating things. It's been there for a while. You don't really need to know this to be able to implement it, as long as you're self-aware on the problem you're trying to solve. Automatically puts you in the right mindset. You know what you need to focus on. And there are many, many other principles. I'm just like listing a few that I deem necessary. Here are some of those from a web application perspective. There's an initiative called Open Web Security Standard, and they focus on getting some of these as a industry standard, and they always are working and iterating through these. And as long as you are aware of these areas, you should be able to figure out easily, okay, what do I need to do in this particular area? How much effort do I need to put in? what's the impact of this in my application? Do I actually need this or not? So many of these are common. The ones that are super, super important are number 4, which is the design. So this is before we start writing code. You might have some sort of solution architect or some sort of a designer who puts together a plan for you to go and develop something. If that person doesn't know or is not aware of some of these decisions that they need to make, automatically it puts you in the wrong spot. So regardless of how smart you are, how aware you are, because it hasn't been in the design, you don't know you have to focus on the areas. So secure design is a really, really big part of our software development lifecycle. But we have like many, many other areas. I'll just leave it here for, now it's open, so you can find it on the internet, but if you want to take a picture, go for it. Now, in order for us to go and do something in those areas, here are some of the really basic stuff we can do. Inputs. We all have forms. We all have the way for user to add something to our application, whether it's their own private data, whether it's something that we allow them to enter, whether it's something that they upload from somewhere else. Input validation is super, super important, not only because the input is the core of our platform and data, so we need to like make sure that whatever data we gather, first of all, it's in the right format. It doesn't have any vulnerability. It doesn't have any script injected into it. Doesn't have any sort of malformed code or anything. But also, this comes back to other stuff. Like, first of all, is this valid in the domain we're working on? Because that's not part of the validation normally. If I'm getting a new shopping cart submitted to my app, is this valid? Can I allow a user to enter a shopping cart with 1 million items in it? So there are some things that from a validation perspective, it's domain related, context related, which is very important as well. Authentication authorization, this is probably the first thing you tackle early on. And this not only comes back to that least privilege from an authorization perspective, it's also coming back to what does the authentication flow looks like for your app? Do you allow people to self-sign up? Do you have manual sign-up process for users? Is this like a multi-tenant application or is this a single-tenant application? So there are many factors that come in when it comes to authentication authorization, and of course we need to know how to get around some of these. There are some really, really good frameworks out there at the moment. There are many great identity providers like Microsoft Entra, like Google, Facebook. All of those have their own identity providers. You can tap into social media login if you wanted to. But it is very important to authenticate, first of all, determine who the user is, and then figure out what is their role in the application so that we can allow them to have the necessary permission. When we gather data, there are two things that normally happen with the data. There is either data in transit, so there is some data going from point A to point B. That's where we probably have to focus less as a developer, but we also have to be aware of it. This could be like using TLS. It could be using end-to-end encryption sometimes, in addition to having TLS. So there are stuff like that. And we also store data in our database. Some data might be less sensitive. Some data might be more sensitive. What are we doing with that? Are we encrypting the data in our database? Or are we using some other forms of data protection like dynamic masking or anything else in that context? How are we handling the errors? If somebody comes into our app, and I'll make an example of this later. If I enter a valid user but the wrong password, what is your app's reaction to it? Does it let me know that the user is wrong? Does it let me know the password was wrong? Or is it like generic enough to say something went wrong, we don't know what, but you have to go and sort this out? It's very important when it comes to reacting to these errors because that might be the source of leaking information to the attacker. So that's very important as well. And of course, logging. We need to have an audit log of everything. In case you're troubleshooting, you need to know the whole stack, like some sort of correlation between something that happened on the front-end side, that happened on the back-end side, the whole session. Code quality. We might have a team of mixed skill sets. We might have some seniors in the team, some juniors in the team. Not everybody has the same background. Not everybody has the same training. Not everybody has the same way of learning even. So what do we do in that space? Do we have a structure where people can review code, comment on each other's code? Do we follow some sort of workflow like GitHub flow, Git flow? That allows collaboration, but that more importantly, if I miss something when I'm coding and I create a PR or pull request, they will know something is missing and they can comment on it. Not everything can be caught by testing. So code coverage doesn't necessarily mean we are immune to all of these errors, as I mentioned before. You might have some tests for the login process. If somebody comes in, enters a user, enters a password, which is wrong, the system should fail that process, which is happening. So that part technically is covered, but is it good to have that covered that way? We also have configuration and environment that we need to manage, so that's of course something that as a developer you might not deal with that directly unless you're working in a DevOps team. We have third-party dependencies. We'll expand on it right away because this is probably the biggest part of all of that. And of course the testing. We'll talk about shift left, which is very important. And the testing of security is not exactly the same as testing the application functionality. Security testing should be separate, and it should happen at various different stages with various different cadences. You might run security testing once a week, but you might run your code testing on every single pull request. So it's different. As I said, we have the concept of shift left, which means if you think about development environment, your laptop, you're sitting there, you're writing code, that's the most left part of that equation. The right-hand side is your CI/CD pipeline and potentially some staging environment, production environment, development environment, test environment. So that whole stack, when we say shift left, it means we need to move all of these testing as far as we can to the left side. If I have to run something on my local environment before I can create a pull request or commit something in my Git even, that's much better than when it's called outside of that equation. There's a study, I haven't brought it here, but there's a really good study done by Panama, which says if you catch a bug, mostly security related, but this might be happening for all the other ones. If you catch a bug during software development lifecycle, you probably spend 80 hours a box to fix it. A developer spends an hour, fixes it, that's it. If you let it go to the CI/CD pipeline, like that goes there, you're probably spending about $240 to fix the same bug. If you let it go to staging environment or testing environment, where there are testers involved, test cases, all of that, you probably have to spend about $800 or more. And if you leave it to go to production, suddenly that same bug that you could have saved $80 to fix it, it's now thousands of dollars cost for you to go and get it fixed. So you see how big it is to shift everything left, which is very important. And of course, again, that comes back to cost-benefit analysis. Do we need to fix this, or can we let it go? It's really about your business. So you are aware, but you need to have somebody who has awareness around the context of what is happening. You can't just decide, I don't need firewall because I'm using cloud. It doesn't work that way. But you need to know, for example, that if you have an application or a platform which automatically builds or has a built-in firewall, then you don't need to spend enough or go outside of that. One thing we could do as a developer is what we call threat modeling. Threat modeling goes through a process of basically visualizing our software. We go through a sort of visualization phase. We gather all the components of our application. We say, hey, we have this component which talks to that component. We have a front-end server and a back-end server and a database and so on and so forth. We model all of that. Then we go and analyze, okay, in this entire stack and workflow, where things can go wrong. There are many tools out there. Microsoft has a free tool called Microsoft Threat Modeling. You can go and design something very quickly. This could be like a simple web app and an API, and it could be in Azure, it could be outside of Azure. And if you just go through and do these two components, the single web app and the API, it gives you probably about 35 different categories of security vulnerabilities you can find and how to fix it. And it tells you, for example, these are fixed by Azure Web App if you are using it already. But these you need to go and implement it in your application. Once we do that, then we can go and start putting those into our regular development cycles. So every sprint, if you think about it, every sprint, if you put a task in there which says, write a single bug which is security related. Every sprint, there should be only one test about security. Imagine how far you could get down the line when you have many sprints now gone and you have a really good code base with a really good set of security related tests. Now, one major thing is, when we say we write code, do we actually write code? 85% of the code that we have in our application comes from somewhere else. We're using .NET, we're using Java, we're using Node.js, we're using NPM packages. Like, I want to just use a simple mathematical operation. I'll go and import a package which has like an add function. That package is like, I don't know, 32 kilobytes or something. But that code is not mine. That code is somebody else's. So it's really important to find out where do we have dependencies, how are we using these dependencies, what do we have which allows us to be aware if one of these has dependencies, and then try to fix those again early on, as early as possible. That's why many of the organizations, the larger one at least, they have a particular package feed that they allow certain packages to be vetted before it can be used by their software development teams. Let's go through a funny exercise. I want everybody here to raise their hands if anytime you want to use a package, you go into the GitHub repository, I'm talking about open source here, and look at the number of stars. Come on, don't be shy, nobody's judging. Who here looks at the number of stars? There we go. Good number. Keep your hand up if you look at the number of issues on the repository. There we go. Keep your hand up if you look at the number of maintainers on the repository. And so on and so forth. So how do we determine if open source package is good for us or not? There are many things that we need to consider. Fortunately for us, there are many tools out there. GitHub Copilot, fantastic for determining dependency vulnerabilities, and it alerts us. It even has a fully functional workflow using GitHub Actions, which automatically can fix some of those for you. Unfortunately for us, if we require NPM or even .NET, we can't rely on the pull request that comes from Copilot. It breaks something. It doesn't really understand how it's the impact of upping a version, specifically if it's a major version, in semantic versioning, how is the impact of that in other parts of the software? It doesn't run tests. We could do that. Again, I just wanted to reiterate that just because you say, I've got 75% code coverage, it doesn't mean that you're secure. It doesn't even mean that you have a good quality code base, right? So there are many, many other aspects when it comes to finding out what does a really good quality test looks like. Let's have a look at this example. When the user enters a username, which is valid, and a password which is invalid, the system should not allow the user to understand whether the user was valid or not. Because if you do so, you will automatically let the attacker know, hey, there is a user with this username. So let's go and explore it more. Maybe we use some other techniques like reverse engineering or something else to figure out what's going on here and get access to the system. So these kind of tests, these are security context-related tests. These are not exactly functional. Functionality-wise, we either reject it or we allow it if it's valid. Let's have a look at the bug types. This is very funny. I like the bugs that are in my face. I see them when I build my app. That's the compile time bugs, right? Super easy to fix. I have to fix it, otherwise I can't ship my code. There are some bugs that are caught by automated tests. Again, simple to understand. We get the bug, we go and fix it. There are some tests, as we mentioned before, that go and get caught in the testing because there are some manual testing done by humans, which might not be covered as part of the automated test. Those are also not so bad. But then what happens to the runtime bugs? What happens when something goes wrong in the runtime? How many of you have used live debugging in production? Do we do that? Well, it's something that it's really scary to do, but sometimes you have no other choice because you can't replicate the code or the bug on your local environment. Similar, typical works on my machine situation, right? Then we have, of course, vulnerabilities, which are super bad. We can't find them unless we do perfect security testing, which we're going to talk later. And of course, if it gets to a point where it's exploited and then we find out about it, that's the worst kind. And there are some pesky bugs. Happen once in a blue moon, and all the stars align. Nobody knows what's happening. Nobody even understands why it is happening. But we have to have something like a tech dev item to go and find it at some point. Those are the ones, probably the most costly ones, because we have to spend a lot of engineering time to figure out what to do. All right, so we know the basics. You know why it's important. We talked about a few things. Let's go and talk about a few particular practical examples and what to do to fix those. Let's talk about handling sensitive data. Talked about encryption. Encryption at the transit, normally using TLS. Sometimes you have to go one level above that and end-to-end encrypt your requests and responses to any application, specifically if the application is multi-tenant or is hosted in a not so secure infrastructure, et cetera, et cetera. Then we have encryption at rest, and there are many techniques out there. SQL Server in Azure supports like end-to-end encryption. It supports dynamic masking. It supports dynamic encryption. There are many options there with different databases, so that's really specific to which platform are you using, which database are you using. But you have to know about these because sometimes really important, specifically if you're dealing with PII, or personal identifiable information. Access control. Talked about the role-based access control, or RBAC. Very important to implement in your app, not only from the user perspective, but also from the environment perspective. What a developer can do in an environment, not just inside the app, outside the app. What do you have from a security perspective versus functional perspective? There are some roles that are related to which part of the application are shown to a user or not. But there are some roles that are security related. I don't want a user with a user level access to get access to an administrative functionality. That's also very important. And again, the least privilege principle here is making a lot of sense. We just need to give every single entity, and it might be a person, it might be a service, it might be something else, the least amount of permission they can do their job without having any side effects anywhere else in the system. And of course, the methods and monitoring and auditing, all of those are important. Data masking, super simple to implement, but very important. If you're, I don't know, gathering credit card information, phone numbers, whatever, sometimes you've seen this already in action in many, many platforms. When you have, let's say, a multi-factor authentication, they will show you only the last part of an email address or the last 4 digits of your phone number. They don't show you the entire thing. That's because if somebody else is trying to get access to your account, they shouldn't be able to find out what's your mobile address or email address. Otherwise, they might be able to hack into that as well. And of course, there are other techniques like tokenization and so on. So what are the common threads here? Well, if we don't allow or don't do this, or input validation, all of that, they might be suspect to regular common attacks, which are again covered as part of the OWASP, like injection attacks. It might be different kind of injection attacks. We'll see an example of this shortly. And of course, we need to mitigate those. Sometimes we deal with some developers that have some unconventional tendencies or beliefs that, hey, we don't need to validate the input. We can trust the user to enter something valid. And of course, sometimes they don't bother validating the right way. So what is the right way? How do we validate an input? Is it just enough to encode, URL encode an input and send it back? Do we reject it completely if there is some sort of a script tag into it? What do we do? Well, every framework has its own way of dealing with all of this. In .NET, we have like model attributes you can put in, which allow you to have some validation, like minimum length, maximum length, the type of data. Even you can have serialization, deserialization techniques implemented into those. The type of HTML that you can send back. Sometimes you have to send a piece of HTML back and render it as is on the client side. You have stuff like sanitization happening for those results or responses. And of course, there's libraries like Fluent Validation, which allow you to go and implement this much, much easier than if you were to write it yourself. So don't reinvent the wheel. Of course, you need to rely on a library, but most of these times, these libraries have done a much better job compared to you trying to rewrite them. And we have the same thing on like browser side. From a JavaScript perspective, we have like form validation, HTML attributes, encoding, decoding, or even a simple allow or block list of stuff that needs to be sent back and forth between the client and the server. Let's have a look at an example. If I have a logic in my application which says every single time you receive an input from a user from client side, remove all the script tags and send it back to the server. I can easily circumvent that using this technique. If you replace the script here with something else, you still have a script. So this code still executes on the client side. This is why we say always reject. Don't try to fix broken data. Reject it completely, let the system handle it, and you are in better shape than if you try to fix this. GitHub had a vulnerability, very funny, that they didn't validate inputs. Somebody created an issue on the Ruby on Rails repository and said, hey, this issue was created like 1,000 years from now. Nobody believed him. Like he just kept creating issues on the GitHub repository. Nobody would listen. And then he went and did this, and the day afterwards, they locked down him from GitHub, first of all. So they blocked him completely, and then they went and fixed the issue, and then they let him back eventually, but yeah, embarrassing. Again, we have sanitization. Understanding what the concept is, implementing it in your application is super important. I don't want to go into details because we don't have the time for it, but definitely go and implement some of those. Again, there are really good techniques, both in .NET, Java, Python, regardless of the library you use. You can always implement these techniques, such as parameterize your queries. Don't send the input as is into your, SQL Server query, right? Use the store procedures if you wanted to validate something, if you're using a database like that. Use some of the ORM features or relational databases features, and of course, again, the Fluent validation is going to be very important as well. So here are the generic steps you need to take to validate input. Normalize, check for length, check for syntax, and then check semantics. This is context or domain-related information, and of course, use the normalized and validated value in your app. Here's an example of one of these attacks, cross-sub scripting. You basically just have no idea what's happening. You get some sort of a request from somebody who's trying to impersonate you. You have a valid application, everything is working fine, but somebody else is trying to send a request on somebody else's behalf. And it's really easy to implement, really easy to implement. But we can easily fix this by using some techniques. .NET has a really cool feature called anti-forgery token. Easily fixing that. It's just one line of code. If you're using Blazor or stuff like that, very super simple to implement. If you're using some sort of a SPA with .NET, still, you can leverage that as well. And here are some techniques which prevents that attack from happening, right? Again, another type, which is a little bit more complex than the other one. So this is like CSRF. Again, easy to implement, as long as your app allows a request to be sent on behalf of a validated user. This might happen. And again, really easy to fix that using same-site cookies, which is a super, super cool feature. And of course, the anti-forgery tokens will help you here as well. Scanning the code. Where do we do this scanning? Well, we said that we need to shift left. So first thing first, I need to scan the code on my end. You might use Git hooks to enforce it for every developer. Before they can commit, you run some sort of a scanning. You might use some scanning tools in your CI pipeline when the app is building. You might use something after that, in a different sort of stage on your CI/CD pipeline. But regardless, you have to run this. We'll talk about what type of scanning do we have. So the what we call the SAST or SAST, which is the static analysis of our software, which happens during the build time. Super important. There are really, really great open source projects for this one. There are some cloud-based free products there as well. And it depends on which product you're using. If you're using GitHub Actions, there are actions available for it. If you're using Azure DevOps, there are tasks available in the marketplace for it. It just needs to do a bit of investigation and integrate one of these into your apps. Then there's the dynamic testing. This is like some sort of a passive pen test or active pen test you could perform. And it's very important to know the difference between this and the static testing. In the static testing, we're trying to find out the code which can cause a problem. In dynamic testing, we're trying to find a workflow, a scenario which can cause a security incident. So if the user does this, then do that, then blah, this might happen. So there's a major difference between these two, and it's very important to run this one as well. But this one, we don't run it on every build. We have to actually run this post-deployment. So if we deploy it to a staging or test environment, we're going to have to run one of these. This might be a nightly basis, might be a weekly basis. It depends on your software. And this one also is a little bit interesting, right? Who knows what this is? Have you heard of this term before? Anybody knows what this term stands for? This is the interactive version of that workflow. So very similar to dynamic, but here we have user interaction in place. So somebody needs to be involved in this type of attack. That's why it doesn't really happen with a tool. Most of the time, it's a combination of a tool and a person. It would sit somebody like expert, and they try to like go through and cause some sort of a security incident to happen. There are some really good tools out there to do this as well, but you need to have training, you need to know the tools. Somebody needs to drive that test. It doesn't happen fully automated, but still very important as well. Now, we need to implement all of these in our workflows. Otherwise, it really doesn't add any value for us. If we don't have this in our workflow, if we don't have static testing throughout different types, and static testing doesn't always need to be happening during the build time. It could happen before that. We could run static testing on a local laptop before creating a pull request. Or the static testing might be even not related to the regular testing we do. We might want to use this for other types of bugs. It doesn't necessarily need to be security related. SonarQube is a really good tool. Not only allows you to work out what are the vulnerabilities you might have, but it also allows you to find out your code smells or any type of like known piece of code which can happen to have caused a previous sort of incident before. So in conclusion, to wrap things up, first of all, as a developer, you need to know some basic principles when it comes to secure coding. And what does that mean from a software perspective? We need to understand some concepts, know what steps do we need to take if we face one of those security issues, need to do this as part of our regular workflows, as part of our sprints. We need to have dedicated security tasks that are designed to fix an existing problem or try to find problems that we might not be aware of. And of course, application safety is not just code. There are many, many other things that we talked about, configuration, environment, infrastructure, all of those stuff also need to be attended to in this book. We're going to open it up for Q&A. If anyone has any questions, go for it.
I'm wearing my Q&A suit. Come on. No one? Really? Someone's got to be first. I will just sit here for 5 minutes in silence then. Apparently they learned everything they need to know, yes. Oh,
We
there's
have
a
a
question.
question.
Hey, fantastic.
I was just wondering about, not necessarily recommendations for SaaS tools, but identifying good ones and how to sort of find them.
So if you follow OWASP, they usually publish a report, which all the, I don't know, vetted tools, if you want to call them. And these tools, some of them are, of course, open source. And there's always a trade-off with using an open source product in these cases. There are really good Docker images that you could use even in like your environment. If you have GitHub Action, you can spin up a Docker which automatically runs a lot of tests on your app. But again, that depends on how far you want to go. Sometimes a free product doesn't do you any good. You have to go and pay for a product and get more professional help in a sense. But if you follow the reports on the OWASP, they will publish a report of all the good and sort of vetted application security tools, whether it's a static or dynamic, they have it all in there.
A question down the back here where you can't see us. So there'll be a voice in the dark, yes?
Hi, I'm interested in your view on, so for a team, this is a lot of information.
A little bit louder, please, I can't hear you.
Sorry. Obviously, learning about this stuff is a huge amount of content, a huge amount of knowledge. So how do you feel about security champions programs and that sort of thing to seed the deep security knowledge into teams?
That's a great question. How do we stay informed when it comes to finding out the best practices from a secure coding perspective? Again, it really is personal. Some of this is like personal flavored. So if you have some sort of a news feed that you set up for your own development related stuff, if you want to stay on top of those, adding some of the security related ones there as well, it's going to be good. Normally speaking, the reports that are published in this space, specifically around security, which highlight, first of all, what happened in the industry, and they publish like a list of all the bad things that happened. What was the cause of it? That's the more important part of it. Was it code related? If it was code related, what was the library that might have caused it? Finding out which libraries are vulnerable. There's a really great public repository from Microsoft which publishes this on a regular basis and allows you to understand which .NET libraries are vulnerable. GitHub Copilot automatically has access to a database which not only covers .NET, like NuGet packages, it covers NPM, Maven, Gradle, all the Java-related stuff, Python packages, and so on. So that's also a really great way to stay informed of all this stuff that is happening in this space. But you definitely need to have a way of keeping yourself on top.